We're going to take out the unit circle chart, and you should already have that complete. We're going to use it to graph the cosine of x. So take it out right now so you can have it right by you when you're doing this. So this will be x, and then we're going to take a look at the values for cosine of x. Let's first start by making a table. You should be able to see this, but let's write it down. These are things you have to know, so the more work you have with it, the better. 0, pi over 6, pi over 4, pi over 3, pi over 2. We'll start with those, and then we'll continue on, and we'll say 2 pi over 3, 3 pi over 4, 5 pi over 6 pi, and after that we'll try to shorten it a little bit. What's the cosine of 0? Remember, we're dealing with our unit circle. That is 1. Pi over 6, root 3 over 2. I want you to be able to know what that number is approximately without having to think about it all the time. So square root of 3 is about 1.73 divided by 2, and we get approximately 0.866 or 0.87. When we graph, we're not going to be able to graph accurately that 7 part. We'll just graph about 0.9. Cosine of pi over 4 is root 2 over 2, 1.4, etc. divided by 2, and we'll get 0.71. Pi over 3 is 1/2. Cosine of pi over 2 is 0. So when we're looking at this, we can start graphing it. 0 is 1. Now we need to put in our scale here. How is pi over 6 related to pi over 2? Well, pi over 2 times 1/3 is pi over 6. And if we look at pi over, and then we look at pi over 2 times 2/3, we'll get pi over 3. Or if we think about it in degrees, for now that might be a little bit easier for you, pi over 6 is 30 degrees, and pi over 3 is 60 degrees, so 30, 60, 90. Now, where does pi over 4 fit in? Right in the middle. Now, first you want to make sure that the first two marks, pi over 6 and pi over 3, basically cut the first interval into thirds, because you need to make sure your scale is labeled correctly. Pi over 6 is about 0.9, so we'll put that pretty high. Pi over 4 is about 0.7, so if this is 0.5, maybe somewhere just under half of that. I'm going to try to line that up. Pi over 3 is 1/2, and then pi over 2 is 0. Come back here. 2 pi over 3 would be negative 1/2. We're now in the second quadrant. And then negative root 2 over 2, negative root 3 over 2, negative 1. So again, we'll cut this into thirds. And we have negative 1/2, about negative 0.7, the halfway in the middle there, about negative 0.9, and negative 1. Instead of doing all of those values here, this basic shape is going to keep on repeating. So what is the cosine of 3 pi over 2? That is 0. The cosine of 2 pi is 1. We can go the opposite direction. Cosine of negative pi over 2 would be 0. And then cosine of negative pi would be negative 1. Cosine of negative 3 pi over 2 would be 0. And negative 2 pi would be 1. So we have 0, negative 1, 0, 1. Now let's first do this first section. Try to get that as best we can, and then we'll copy that shape. And it's looking something like that. So it starts off high, and then it comes down. And we just, at this point, kind of connect the dots. I'm planning on showing you in class doing this on the computer, and you'll see a pretty neat way that it's done. Before we go on and do the rest of this, actually we can do the domain right now. What's the domain? Domain is all real numbers. We can find the sine or cosine of anything because we can continually go around the circle in either direction. So it would be x such that x is a real number, is the set of the real numbers. What's the range? Well, we can look at the x values of our unit circle. The very highest is 1, the very lowest is -1. We can also see that in our graph. The high is 1, the low is -1. So our range is between -1 and 1 inclusive. And what is our period? The period is how long does it take to repeat? What's the smallest section if we copy that? Well, we look at this, we're back at 1, and then it's going to start going back down, etc. And the same thing's happening over here. How long does it take to get back to that +1? It takes a period of 2 pi. Does that make sense? It should, because how long does it take to get back to the original spot on the circle? Well, one circle is 2 pi. There's another way to graph this. It's really the same, but the scaling is a little different. Instead of labeling convenient numbers, we label just this natural way to do it, 1, 2, 3, 4, 5, 6, etc. Now, in order to do it this way, instead of doing all of these numbers here, let's just do the kind of convenient ones. So what are they? And that's where it hits the high point, the middle point, the low point. So 0, pi over 2, pi, 3 pi over 2, 2 pi. Now we've gone over what these fractions are. Pi over 2 is about 1.57, so it's close to that middle spot. Pi is 3.14, so just past the 3. And it's going to be -1. 4.71, here's 4 is 5, is about 3/4 of the way to it. And then 6.28, about 6.3. And we can go the exact opposite way, -1.57, -3.14, etc. So if we do this, now one of the things why the first graph does not have the same scale for the x and y axis. I need to change that to make that look a little better. It's more convenient to graph it using the pi values. Etc. So it's looking something like this. Now, this will be a nicer way to deal with problem number 3. When I say graph y equals 1/4 x on the same axis, what I meant to do was for this natural scale. How many solutions are there?
If you are on campus, can you please report to the main building? Thank you.